Alright, we have an equation of a tangent question. So we're given the original function f of x, and just looking at it, I see x to the power 3 is the highest power, and that has a negative coefficient. So I know this graph, if we were to graph it, would be a negative cubic, something like that. And actually at this stage, if you're a bit unsure, you can graph it on your calculator, just to get a feel for the question. Alright, so we know it's a negative cubic, but we're asked to find the tangent at the point 218. So I'm not too sure where that is on the graph, but let's say if it was here, at that point 218, the tangent, that line should intersect, right? We're looking for the equation of the straight line. That is tangent at that point. Alright, so a few steps for this one. So step 1 would be to find the derivative, right, the gradient function, f prime of x. Step 2 is to find the gradient of the tangent line using the gradient function. And then step 3 is to find the equation. Alright, so let's go through that now. So step 1, finding the derivative, f prime of x. So let's have a look. So the derivative of 6 is 0, because if we plotted 6 on a graph, y equals 6, its gradient is 0, it's a flat line, so 0. The derivative of plus 14x is plus 14. The derivative of minus 2x cubed is taking the 3, multiplying it out the front to give minus 6. And then x to the power of 3 minus 1. Right, subtracting 1 from the power. Awesome. And just to write that a bit more cleanly, we don't need the 0 out the front. So we have found f prime of x, right, the derivative. Second step is, since we have that, we can find the gradient of the tangent line, because we know that it is at the x value of 2, right, on the graph. So using our gradient function, f prime of 2 equals 14 minus 6, n for x goes 2 squared. So 14 minus, what is that, 2 squared is 4, 4 times 6 is 24, 14 minus 24 is minus 10. Great. And so this is the gradient of f of x at x equals 2, which is equal to the gradient of the tangent. Right? And that's the definition of the tangent. It has the same gradient as the function at that point. Alrighty. So we found the gradient of the tangent line. Last step is to find the equation. So tangent line, we know the general form of the equation of a straight line, y equals mx plus c. We just worked out the gradient of the tangent line, and now what's left is to find c. Alright, so equation of a straight line, we know if we have a point, we can substitute it in for x and y, and then solve for c. So using 218, because that point is on the tangent line, in fact it's where it intersects the graph, but as long as it's on the line, we can use it to solve for c. So substituting in 18 for y, m we know is negative 10, substituting in 2 for x, and then solving for c. So 18 equals minus 20 plus c. adding 20 to both sides, we get c equals 38. So putting it all together, so equation of tangent line is y equals the gradient minus 10x plus the y-intercept, which we found was 38. Alright, and then we found the equation. So just to recap this question, we started off by finding the derivative, right, f prime of x, and we used x equals 2 to find the gradient at that point. And if you got that far and you found the gradient, you would get achieved for this question. We then went on to find the equation of the tangent line by substituting in that point 218 to find c, and then stating our equation. If you got all the way to the end, you would get merit for this question. Well